Hey, good day, viewers. My name is Gandhi Kumar, and I'm in my MS in telecommunications program, and this is my first semester. So today I'm going to talk about TCOM 5123 upper layers, and the topic which I've been given is network design considerations for multi-campus slash building organizations. So basically, before I get on with the presentation, I would like to talk about what exactly do we see when we see a network? If I'm starting an organization and I have many branches, I need connectivity. So the simple steps: I have a firm, I have many locations, and I need it to be connected. So it depends on me and my users and the business requirement, so as to what kind of traffic I need. So let's just get a pretty gist before I get started. So this on this document sheet. So let me just put this across. So I'm talking about a landscape, and I have an office here, and across the globe somewhere far I have another office, and then I see more business growing, and then I set up another office, and then it goes on. So multiple organizations like. This is my headquarters, okay? So multiple organizations like, if I were to say Google or Microsoft, these people have expanded tremendously. So somewhere or the other, I need to have a solutions team or a network design consideration team to accommodate all the changes, to accommodate the growth, to accommodate the expansion. So how am I going to do that? So today's presentation, I'm trying to keep it as basic as I can, and gradually increase the step one by one, so that even a layman watching this should understand it very clearly. So let me just get on started with this. So today here we see network design considerations for multi-campus and building organizations, and let's see our agenda for today. So first is the topic discussion. We'll discuss on what topic we were given. We will see the basics of network traffic. That means what do these terms mean, or where do they make sense, like flexibility, scalability, peering, transit, NNI, last mile. These are very familiar terms we go across from a day-to-day life, but then where do they make sense? What are the types of service? What do I mean when I say ILL? What do I mean when I say VPN, MPLS? And what are the topologies? What do I mean when I say a GRE? And what are the solutions? Now this is the interesting part. After we complete the elements of ISP or from an enterprise or an ISP perspective, we will see what are the solutions and how in actual does a solutioning take place. What actually happens when an RFP, that is a request for proposal, is given to many service providers by an organization. How do they go on step by step? And we'll see a summary and conclusion of the same. So I'll just read out the topic which was given to me. It was like, the company I work for is expanding. We are currently building 3 new plants. Now I'm taking into consideration our headquarter and a couple of 3 plants, and then 3 more. So that makes it a headquarter and 6 plants. And so this guy says, in order to accommodate this, obviously our IT resources will have to expand as well. Yes, you need 3 more plants, and then you need to increase the hardware. You need to have more connectivity. And so he likes to get people's opinion on alternative network domains. The constraints are distance between the plants. How am I going to bridge that? How am I going to use my existing network? How am I going to take into account the domain infrastructure, the budget situation? And the second question also somewhat sums up the same. He wants in terms of cost, amount of equipment, maintenance, carriers, and how am I going to protect it from data breaches? Let's just go ahead. So the first term which comes into a consideration is flexibility. Now, what do I mean by flexibility? It's used as an attribute for various types of system. Like, in a simple term, when I say flexibility, it's like, how adaptive is it? How adaptive can my network be? It refers to the design changes which can occur once my network is set up. It's like, I have XYZ. So just to put it on in a document. Now I have 3 plants, as the guy said in the example. Okay, these are my 3 offices, 1, 2, and 3. Now, eventually, what happens is, somewhere deep down the world, I'm getting good business from Australia. That's right, way down there. Okay, so I'm getting solid business from there. Now this is a new site for me. How am I going to accommodate this into, let's say we have an existing setup, a hub and spoke terminology. How am I going to accommodate this into this so that there is business happening between this office and XYZ, say 1, 2, 3. How am I going to accommodate that? So that states how flexible can my network be. And the next factor which we're going to see is something to do with this as well. That is to do with scalability. Now, when I say scalable, is the ability of a system to handle growing amount of work. Now, if I have more organizations and more, work locations, off-site locations, on-site locations, now that means more traffic coming in. How am I going to accommodate that? Now, that's the next part of telecom. How scalable is going to be my network? Now, we'll see peering. Now, I'm kind of rushing here, but then I need to accommodate. What do I mean when I say peering? Now, this term is pretty simple. When I say peers, P-E-R, that's like two people in an organization who are at the same designation. So if you see here in the presentation, there are three examples of three service providers: WestNet, MidNet, and EastNet. Now, these three service providers are spread across in a country. Let's take the example of the United States of America. Now, they're spread across, like one is the West Coast, one is the Mid, and the other is the East Coast. Now, these people, they have limited amount of capital. They cannot invest, they cannot cover the complete of Americas. They need to rely on each other. So they will actually go ahead and peer with each other. That means they will allow each other to share the routes. Now, what do I mean by that? As in, now EastNet has got a customer right all the way from the west side of the USA. Okay? Now, can he say a no to him and tell him, boss, I'm sorry, I don't have connectivity there? No, they don't do that. They accept the deal if it's viable and it suits their business requirements, and they're getting their profit out of it. The ISP will go ahead and talk to WestNet and try to see if these routes can be advertised, vice versa. And the same goes with the other two. MidNet will do this for left and right, and then WestNet again for both of them. Now, what do I say when I mean by an internet transit? Now, transit, and this is a popular word you come across when you're driving, right? So this is similar to that. When I say internet transit, it's like, internet service provider connecting to a larger internet. Now, the previous one which we saw was a peering. Now, what's the difference between both of them? When I mean by peering, it's like two tier 3 internet service providers exchanging routes to each other. But then these people have connectivity to the internet. I'm talking about the exchange. I'll come back to that later in the presentation. Now, when I say transit means a broadband provider going ahead to a tier 1 provider who in turn goes to an internet. Now what do I mean by that? Now, locally, if you see, AT&T will never come to your home and say, hey, you know what, do you need a broadband? They are the bigger players. So, for example, Chicasa Telecommunications. Now, these are guys who will cover a local area, right? He'll give you a DSL, a broadband, and now that's how your internet, like Suddenlink. Now, Suddenlink is not a big player. He has a particular area covered across to him. Now, Suddenlink will take the services from you. You might not need a bigger business link if you are living in an apartment. You will say probably I'm good with a 54 Mbps broadband, and you don't have any traffic segregations. All you want to do is browse the internet. So all the traffic is going to be, most of them is going to be data. You might make a couple of Skype calls. Even that's not high priority. You're not going to have VCs like CEOs having across industries. So you're good with normal internet. Now Suddenlink will get it for you. And where does Suddenlink get it from? He's going to get it from a bigger service provider like AT&T, Verizon. Now I'm going to give an example of US in the complete presentation so that we all are on the same page and you don't come across unfamiliar names like Tata Communications and Vodafone and Singtel, which might put you into a dilemma. Right. So now what happens when I say tier 1 to internet? Now what exactly is internet? Internet is many people coming and getting things connected. So I have an IX or an IXP. What I mean by that, an internet exchange point is a physical infrastructure through which internet service providers exchange traffic between each other. So everyone pulls in. So these are the basic elements I want to cover. Like, this is the difference we are seeing between transit and appearing. Now this is my internet backbone. Okay. So now any customer or any user will use a transit to connect to a local provider, and this guy in turn will have appearing with a bigger provider, and then this can again go into a transit of route exchange, and eventually this is a transit between the tier 1 networks. Now this guy is the big player. He has a stronger network hold, he has a much established network, and many internet exchange connectivity points. As I said in the previous slide, it is where multiple ISPs exchange traffic. Let's go to an NNI. Now similar to this, now NNI is a network interface exchange. So what happens here is, like the previous example we discussed was of MPLS, or was of ILL, or say internet. Now when I come to MPLS, which I'll cover in the later part of the presentation. So now I have a customer edge router, and I have a provider edge router, and I have my MPLS cloud. Now if I want to connect to another MPLS cloud, that is where MPLS is private, right? It's not like you had your internet exchanges wherein you can exchange routes directly. MPLS is more to do with that. Now you're handling private traffic when no one in the world can access this until and unless the ones who are originating and designated for. So NNI will help you connect between two autonomous systems. Now let's see what's a last mile, what's a OLO, what's a LEC. Now the previous example, if you could see, if you could see, now this is my cloud as an internet service provider. I have an edge router at my provider end, and I have my customer router. Now I am a big player internet service provider. I don't go into local links like I said, right? AT&T will not come to your home and tell you, let me give you a broadband. Rather, Suddenlink will. So when I come to this edge, for example, I come to Oklahoma City. This is where my edge router is, and then someone from Broken Arrow or Wichita or Tulsa is asking me for a connectivity. Will I deny him? No, I won't. I want to do business. What I'll do is, I'll take this leg, the line which you see here, from a well-established local player, which is basically OLO, other local operators, or last mile providers. The last mile is the last kilometer freight, which is used in telecommunications, which gets the link delivered to the customer. And even there's a catch. When I say OLOs sometimes come into splits and segments as LEC portions as well. What do I mean by this? Now, some countries have telecom regulations. You can bring the traffic right till the customer office, but then the last exchange from the customer outside premises to the customer data center, or to the rack, or to the router, will be bought by a LEC provider who is the monopoly in that particular country. For example, if you see in UK, BT is the LEC wholesaler, he is the monopoly. So now BT has to be given that segment, whoever is connecting to whatever. And so these last miles are usually based on, they can be on copper, fiber, RF, 3G, sometimes on LTE as well. So let's see the types of services. They are internet lease lines. As I said, managed internet access, wherein someone wants to connect from an exchange. Now this is going to be till the office, to the internet. I'm going to browse. My business requirement is nothing to do with anything private. All I'm going to do is e-business, like say now I'm having an office here. These are customer care executives, and they are going to there are people who will call them and tell them, I need to book this. Do the booking telephonically. Now these people are going to access the internet. And if you need a very strong or a very big data size, you might want to go for a lease line. And then this is one option. The other one is I can use a lease line to connect a head office and a remote office. Now, what is with ILL if I say hub and spoke? Now, this is basically I'm so sorry. This is basically a HQ headquarter location connecting to many small sites like Stillwater, Oklahoma, Wichita, Tulsa, Broken Arrow. Now I have many offices here. For example, I'm doing a textile business. Now I need to make sure from the headquarter or from the warehouse to ensure what stock is pending or what stock is less or what is more. So I need to have individual connectivities. This has nothing to do with private ones. It's like connectivity between me to my office, in a distant location. Now, if the red lines you see are point-to-point lines, like if I feel this office needs to talk to Oklahoma as well, but then I can't rely on this line itself. I need a protection. Instead of going from this to here, I want to go from there to directly to Oklahoma. Now, this is a basic setup with an MPLS. So all these segments which I'm covering are kept into mind the final stage which I'm going to touch base. So that'll make sure we sum it up. So if MPLS, if you see, as I said, we saw previously, we have edge routers and we have core routers. This is like within a country. If I go for a VPN or IPsec, now what is a VPN and IPsec? Now I have internet, but then I need a private line within that. And that's exactly what VPN is going to do for you. It's going to provide you a virtual private network within an internet circuit. Now I have customers like in head office who are based in the office. I have customers in the regional office who are again in another regional office, and then I have users who are roaming. Now these are mobile users, salespersons. Now I cannot tell them you need to be in some office. They're roaming users, so I might as well give them a dongle to connect to the internet, and then to ensure I have a secure, I might give them an RSA token so that when they do a dial-up in that token, they have a secure connectivity established between their laptop or their smartphone onto my head office. So that makes it as good as they are on my LAN. So this is, I'm calling someone away from the internet onto my LAN. That's what it means. It's like extends a private network across a public network such as the internet. Now it is pretty secure using IPsec protocol. Now there were concerns raised on security by the person who asked me the question for this presentation. So now internet protocol security is a protocol suite for securing internet communications. Now this will make sure using cryptographic keys and certificates that my traffic or my VPN traffic is pretty secure and no one is barging or tapping it. Now it can be used in data flows between host to host, network to host, and a network to network connectivity. And it's one of the most secure ones available currently and used globally. Now, the one option we have is GRE, which is a generic routing encapsulation. It's a tunneling protocol developed by Cisco, and it's a Cisco proprietary that can encapsulate a wide variety of network protocols inside point-to-point connectivity over the internet protocol. So it's like I have two options. I can go with either a GRE tunnel and make it from one office to the other. I can go with a VPN option for my roaming users or my fixed users based far away from their headquarters. Now this is the interesting part. This is how I'm going to set it up. Now, for example, I have an MPLS tier 1 POP. I have a customer site and I have a customer headquarters, and this is spread across the US. Okay. Now this is the headquarters, and these are, let's say, AT&T. The black ones with the cross, the AT&T tier 1 POPs. And the customer requirement is you want to connect to a tier 1 POP. Now these are cities like California, and then Oklahoma, and then New York, Newark. So how am I going to connect? So if you just see a basic understanding, all these black ones are the MPLS POPs. They are connected. They have a protocol, a BGP or OSPF session, usually a BGP or MPLS established between them. Now these sites are going to talk to the headquarters or sometimes to each other depending on the user requirement. Now this is a country level reachability. Now let me cover a state level reachability. Now for example, this is my customer hub location, and these are tier 2 POPs and these are tier 1 POPs, and the red ones are customer sites. Now I have one in St. Lawrence, say one in Hamilton. This is the New York map, and one in Oswego. This is my hub. And then, for example, an office pops up in Delaware. Now, how do I get this guy connected? Now, we have many options. If you want an MPLS, usually when does an MPLS being used? It's used when someone has various types of traffic to accommodate that. Someone wants to connect point to point, will be an ILL. Now, this is a global level setup, again, between various countries. I'll just skip across this. Now, let's cover these segments one by one. I'm sorry, the screen. Okay, let's cover these segments one by one. Okay, the first constraint was the distance between the plants. Now, how am I going to accommodate the distance between the plants is simple. Go to an ISP. Now, I have a hub location, say, just show that to you here. I have a hub location here, and I have, a spoke location here. And then it's fine. I have an internet service provider in the midway who can give me connectivity between both of these. But what if I have a hub location somewhere else? I don't have my connectivity there. Now I have an established ISP. Okay. Now let's consider that situation. Okay. I have an established ISP. I'm with AT&T. I have a hub location. It's just put it across. I have an hub location, and then this is my spoke. I come across as I told you in the start, my business increases. 2 new locations, one in India, one all the way in China. And my ISP has no connectivity there. Now I go to him and say, hi AT&T, my business is increasing. I have 2 new sites. What are you going to do about it? Now, do you remember I explained to you all those segments? Scalability, flexibility, NNI, peering, all these come into picture. Now, that new site will be a solutions architect will try to go through that area, try to see the providers there, and try to see how he can get that traffic onto here, depending on whether it's MPLS or ILL. Now, the existing network, I'll be covering that in a couple of moments, the domain infrastructure and the budget situation. Now, let's just go ahead. Now, this is where it gets interesting. I'm going to take you on to actual live scenarios. 3 big service providers, AT&T, Verizon, and Sprint, go onto their site and check what exactly is happening. Just a second. Now, this is the Verizon site. So if you go here, I get an overview. I get what do you want? You want a private IP, you want a PIP wireless, you want a private network, an Ethernet, a managed WAN. So when you go here, you can go for a request for a consultation. Now, these people will do a research based on where the location is, what the bandwidth requirement is, what type of traffic are you going to segregate, and accordingly provide you with a solution. Now, it's pretty interesting. The cost comparison between these vary as much as it would in any other country or service provider. Now, coming back to the presentation, I'll just skip across these. Now, what's the difference between a lease line and an MPLS? Let me just come across here. Second. Now, the scenario 1 is wherein I have video, voice, and data. And my second scenario is purely internet. Okay. So when I have segregated class of traffic, the best preferred one is an MPLS, which is the trend in the industry. So what advantage an MPLS will give you is basically it'll give you security. It's going to give you class of service, rather more prevalently known as QoS, quality of service. It's going to give you the scalability and flexibility in MPLS is way too high. I just put a scalability and flexibility in MPLS is way too high. That is, I have a POP. Okay, this is my HQ, and I have a couple of locations. Now, I don't need to actually have hardware to connect these sites to a different one. Now, if I have a couple of more popping up, I can talk to the service provider usually, and when these people have local internet connectivities between these 3 sites. And the best advantage of MPLS is it is very easy to get these to talk to other 3. You don't have to have a dedicated line. It is purely done on RT, that is the route target, and the route distributor. And the main term which comes into play, virtual routing forwarding. What it does is when I segregate the RT for a particular class of traffic in the VRF, is going to create a virtual path between these 2. So these 2 are going to talk. Now I don't have to set up a different lease line here. Now this is the advantage of MPLS. So as a guy said, how do I accommodate 3 new sites? You can go for an MPLS option. You can check with the provider. You will get a voice, video, data segregation if your setup demands that. But then if you have a different business type of network, wherein your business is basically talking to the internet, and these are your 3 sites connected to these, and then they want to talk, you have a couple of 3 more, and these talk to the internet as well, you can just connect them to these. Now these sites are not going to talk to others. This is like a hub and spoke. Users are going to get connected to the internet. Now, the scalability and the flexibility option, as you see, if I just come back to this and compare both of these, Leased line is the most secure. MPLS eliminates a feeling of the dedicated line. Both are equally reliable, trustworthy. This is point-to-point. MPLS can give you that multi-point advantage, which my questioner was requesting. Both guarantee you high speeds. This one, QoS enabled on request. MPLS is guaranteed QoS. Both have 24/7 monitoring, and some of the characteristics are similar. But then the best advantage, which I wanted to dominate here, is point-to-point and multi-point. Now, router choices. Now I'm setting up, my office. Now I'm coming to the LAN side. Till now I was talking from the transition from an ISP to an enterprise. Now I'm coming on a LAN. If you can actually see router choices. Now if you can see, this is what Cisco says. I'm going to stick to Cisco for this presentation, and it says if I can use an 800 series for a small office or a teleworker, you must be seeing this at your homes. I can use an 1800 series when I have branch offices and big offices. 2800 series. Usually these are the ones which are most predominant in LAN and in corporate offices. Now, when I'm talking about an ISP, I step up another level. I can use this 7600 series, 7X series, and of late the 12,000 series are used for the route reflectors as well. Now, route reflectors are basically, in a layman's language, connected to all the core routers, having multiple BGP sessions, trying to avoid them talking to each other, increasing the CPU, and then getting the routes sent across to each other. Now, after router choices, if you see 800 series is for approximately 25 users, 2800 series for 50 users. So the network administrator can plan his requirements. You can find the price of these on the Cisco website and then choose accordingly what your budget is going to be. And then you have this for a campus or a large headquarter or an office. Now, switch choices, similarly, what kind of port speeds do you need to connect your user desktops or your user systems, laptops onto your router? You're going to get it via a switch. That's the best preferred method. Use what's the bandwidth requirement, the power requirements, the performance requirements, whether it's going to be sitting on the edge core, it's going to be a distribution switch. The physical and environmental, the rack requirements, the height, depth, even that has to take into be consideration. The support given by the vendor, and the manageability, and the OS. In short, as I just explained, MPLS, it's about routers, switches, and multiplexers in a ring. Tier 1 routers, Tier 2 and Tier 3 are for like town and not cities. NNIs, peerings, and the VRF, which I clearly explained before. So let's just summarize things. We saw what current network study was. We saw our internet service provider analysis. We saw the cost comparison between Verizon, AT&T, and Sprint, and how exactly it varies depending on so many factors. Like my peering will be free of cost. I'll be just exchanging routes. But then when I'm talking about internet transit, I'm talking about sending my routes to a tier 1 who will send it across to an internet exchange point. So that's going to cost the service provider money, who in turn will float the cost across to you. So you need to take all these into considerations and plan your budget across. We saw the criticality of a site and then going for a secondary or redundant option. We saw MPLS and commodity internet combinations like IPsec tunneling. That's what we saw. VPN tunnels, GRE. We saw QoS quality of service based on traffic, which MPLS provides. We saw the number of users and traffic applications, efficient choice of routers. We saw ISP versus enterprise comparison. So that's about it. You're free to ask questions. I try to summarize things from the transition from an ISP, how it goes across to an enterprise. What are the points involved in an ISP, and what all can, because remember, the stats are simple. If the ISP is going to get charged for something, you're going to get charged for something, and the capital is just going to float across to you. So you're talking about a different location where an ISP does not have a reach, and he's going to buy it from some other ISP, like a transit or peering. That cost is going to come on to you. So you have to plan and think about what you want to do. So if you really feel that cost is going to go way more higher, you can buy an internet connectivity at that site, get that site connected onto the local internet, and get a VPN or IPsec tunnel onto your private network. That's about it. Thank you so much for your time. I appreciate it.